I'm Dave Adamson with GSI Environmental, and with me is Poonam Kulkarni, also from GSI. Today we're talking about noise from military testing and training and how the Department of Defense can accurately monitor the noise they create.
Military bases produce a lot of loud noises through testing and training, which affects those living around them. A big part of the issue is blast noise from explosives, which can carry for long distances while staying loud. Blast noise can cause the DoD to receive damage claims from neighboring residents and can force them to change training times or even relocate whole facilities.
So a major issue that the DoD faces is that their current noise measurement systems are inadequate. For these devices, wind noises can create false positives, making it more difficult to interpret the results. They also can't function in all weather conditions, and they must be manually accessed on a regular basis.
So if the DoD can't accurately measure the noise they're creating, then they can't effectively mitigate that noise. So noise monitoring is needed to determine which complaints are legitimate and which actions generate the most noise.
Right, so you can imagine if the DoD doesn't know which exercises will be disruptive, they really can't plan around them.
To remedy this problem then, ESTCP sponsored this project titled Improved Military Noise Monitoring System to create a new, better way to monitor the noise they generate.
And the PIs of this project, the folks that actually did the work, are Dr. Edward Nykaza from the Army Engineer Research and Development Center, Jeffrey Alanak from the Applied Physical Sciences Corporation, and Dr. Jeffrey Vipperman from the University of Pittsburgh.
Well, let's start off by describing the objectives of this project.
First, the system should accurately detect and classify military noise. It should be able to determine what is noise caused by the military and then classify it into groups such as blast noise or aircraft noise.
Second, the system should reject non-military noise such as wind, and false positives should be minimized.
Next, it should be able to run in all weather conditions for long periods without maintenance.
Finally, it should be easy to use, and the data generated should be easily accessed and analyzed.
Now, to solve these problems, the project team developed the Bearing and Amplitude Measurement and Analysis System, or BAMAS.
This system can detect and reject non-military noises such as wind. It also uses an algorithm to group military noises into different categories. This process works because different noise sources produce different sound waves, as you can see from the image. And so the algorithm can sort incoming noises into categories by comparing the sound waves.
Okay, so what's shown here is a diagram of the BAMAS system. It has tetrahedral microphones, and these capture the incoming sound and its direction, while the weather vane and reference microphone give further information about the detected noise. The system then analyzes the incoming sounds and sends that data to a base over the cellular network.
Another feature about the system is that multiple monitors can triangulate incoming sounds. By seeing the origin of noises, users can then pinpoint the time and location of noises that are excessively loud and then work to fix the issue.
Now remember that one of the objectives was ease of use, so the data output is designed to be easy to read and analyze. You can view this data both historically and in real time. The image shows that the location of the noise is overlaid on a GIS map. The data can also be exported to Excel and other analysis programs, and this allows users to work with the data that they receive.
The BAMAS team demonstrated their technology over a 12-month period. The goal of the demonstration was to show that the BAMAS system can meet the original objectives: running unattended in all weather conditions, effective noise and classification, and a high rejection rate of non-military noise such as wind. In these cases, a threshold of 90% was expected. And so in this demonstration, 9 monitors were installed to cover 100 square miles of area. Over 12 months, the system received 33 million noise events and filtered those down to 450,000 military noises. So Dave, how did the BAMAS system perform?
Well, in all categories, the PIs were able to show that the system worked really well. The system had a 97% operational uptime, although self-service outages meant that real-time data was only available for 91% of the time. In any case, of the military noises, 92% were correctly classified, which meets that 90% guideline. And finally, the system had a really high rejection rate of wind noise of over 99%. Over that entire 12-month demonstration period, they only saw 1 false positive due to wind.
Pretty impressive results. Now let's review the key points of this project. First, military bases have a problem accurately monitoring the noise they create.
And to solve this, the BAMAS system was developed to detect and categorize military noise. It was successfully shown to eliminate false positives from non-military noises. It was able to determine the location and time for every noise, and it was also shown to operate in all weather conditions without extensive supervision.
Well, that wraps up our talk for today. Now I'd like to direct our audience to the CERDIP ESTCP website at cerdip-estcp.org, where you can find more information about this project. And remember that this is one of a number of CERDIP and ESTCP project summaries here on the CERDIP ESTCP channel. Just go to YouTube and search CERDIP/ESTCP micro lectures to see more of these short, focused graphical project summaries.